Hi there, this is Physics, Chapter 6, Work, Energy and Power. Lesson 3, Kinetic Energy. Now in this video, I will try to help you understand about kinetic energy. So let's have a look at what you will learn from this video in more detail in the next slide. Right. First, you will learn about what is kinetic energy. And kinetic energy has this symbol EK. And the second point is that what affects kinetic energy. The third point is you'll be able to answer how to calculate kinetic energy. And the fourth point is how is work done related to kinetic energy. So let's start our exploration here. Kinetic energy is defined as the energy of a body due to its motion. The SI unit of kinetic energy is joule and given by a capital J. Take note as well, kinetic energy, it is often that we refer to it in short as capital E and a small k. Okay? Right, so let's try to understand more about kinetic energy. Kinetic energy can be simply understood as the energy of a moving object. So in other words, if the object is not moving, the object does not have any kinetic energy. So let's now try to understand a little bit more about kinetic energy. We know that it is the energy of a moving object. Now let's have a look at this diagram. We see two vans of the same type. Both of them have the same mass. However, let's assume that the green van is moving faster than the red van. So the question is, which van has more kinetic energy? I bet you know the answer. If you are thinking it is the green van, then you are right. Indeed, an object that is faster, it has more kinetic energy. Okay, so in other words, to summarize, this simply means that for the same mass, the faster the object, the greater the kinetic energy. Now let's have a look at the second diagram. In this particular diagram, we see that we have a truck and a motorcycle. Clearly, the truck has more mass compared to the motorcycle. So, if both of them were to have the same speed, moving at the same speed, for example, which do you think will have more kinetic energy? So if you are thinking the truck, then that's correct. So in summary, objects moving at the same speed, okay, the greater the mass, the greater the kinetic energy. So from the previous slide, we can clearly see what affects the size of kinetic energy of a moving body. First, that will be the mass of the body. And secondly, that will be the speed of the moving body itself. So knowing that now EK or kinetic energy depends on mass and speed of a moving object, we can now calculate the amount of kinetic energy of a moving object. The formula that we use is simply this. EK, capital E and the small k is equal to the half, equals to half times m, which represents mass, times v, representing speed, square. Okay, so let me just repeat that again. EK equals to half mv square. Now, take note of some of the symbols here that we are using as well. I mentioned earlier on, m or small m, take note of the capital or the small letters here. This is important. Small m represents mass of a body, and take note that the mass of the body has to be in kilograms, not grams, but kilograms. Small v here represents speed of the moving body itself, and the speed of the body has to be in meters per second, not centimeters per second, not kilometers per hour, but meters per second. And just to recap, the SI unit of kinetic energy, EK, is joules, capital J. So let's have a look at a typical problem or question involving kinetic energy. Now in this problem, we have a toy car with a mass of 4 kg which was originally at rest. When the engine is switched on, it accelerates from rest, and after 10 seconds, the speed is found to be 2 meters per second. 5 seconds later, its speed is found to be 3 meters per second. So the first question is this: what is the EK of the car when it is at rest? Explain. Now let's recall. Kinetic energy is the energy of a moving object. So at the beginning, when it's at rest, we know that it does not possess any speed. Therefore, the EK of the car or kinetic energy of the car at rest would be 0 joules. Okay. Now, to answer the second part, calculating the EK of the car when its speed is 2 meters per second. So, let's recall that the formula to calculate the amount of kinetic energy is half mv squared. By writing that down, we will have this. EK equals to half mv squared, and substituting m for mass, which is 4 kilogram over here, and at 10 seconds, when the speed is at 2 meters per second, we substitute into v and square that. Calculating this, we'll get 8 joules. Alright? And for the next part, is the EK of the car when the speed is 3 meters per second more than that calculated in part B? Well, that is very obvious. When the car is moving faster, the kinetic energy of the car will be much faster than at part B. Now, in this slide, let's have a look at how to relate kinetic energy to work done. Now, I'd like you to recall this diagram from lesson 1. The hand pushes on the box, and this actually causes the box to move in the same direction as the force. From the previous lesson, we know that the work is done by the hand. Alright, and this amount of work can be calculated by simply taking the force applied by the hand and multiplying that with the distance moved by this box. Now, let's assume that there's very little friction present between the box and the floor. So if that's the case, the force applied on the box will be able to move it very easily. In other words, we just need very little force to move the box. Even then, we recognize that there is some work done, right? So as a result of this work done, the moving box would have gained kinetic energy. So how do we then relate kinetic energy to work? Simply by this. The amount of work done by the hand will simply be equal to the kinetic energy of the box. To understand that a little bit better, let's use some numbers here. Alright, so for example, if the amount of work done by the hand is 3 joules, these 3 joules will be the same amount of energy that the box would have in terms of kinetic energy. Alright. So, what happens if there is friction present? In reality, there is always friction. Alright. So, what is going to happen? Well, you know that for a fact, if there is friction present, we will definitely need more force to move the box. In other words, if we to apply more force to move a certain distance, this will mean that there will be more work needed as compared to the situation whereby there is no friction present. So, in order to move the box and to overcome friction, the amount of work done by the hand now will be equal to the kinetic energy of the box plus the amount of work done that is needed to overcome friction. So let us assume that the amount of work done by the hand now has increased. In the previous slide, if the amount of work done is 3 joules, right now when friction is present, the amount of work done is more. So let us assume that the amount of work done by the hand is now 5 joules. In order to move the box, okay, the box which is moving, it will have possessed kinetic energy, and let's say the kinetic energy of the box is 3 joules. So therefore, the extra 2 joules is used to overcome friction. Okay? So that brings us to basically the last slide of this video. Right? In summary, kinetic energy. What is kinetic energy? It is essentially the energy of a moving body. Once we know that, we will need to know how to calculate amount of kinetic energy as well. So the amount of kinetic energy can be calculated by this formula, half mv squared, where m represents mass and v represents speed. Again, I would like to emphasize that the square, the 2 here represents v squared, not v times 2. And the last question is, what affects kinetic energy? Well, we have learned that there are 2 things that affects kinetic energy. The first is the mass of the body in kilograms and its speed in meters per second. Right. Thank you for listening.